Okay, welcome back guys. So today is a Div 3 contest. I hope I will be able to solve 3 questions. Games on a train. ABC just got on a train and decided to play a game. DEA, okay, I'll call them DEA. D has a backpack with an infinite number of cubes. He built n towers from them, where the I tower has a height of hi cubes. He built n towers of hi cubes. E and A must choose an integer xi for each tower and increase its height by xi exactly once. For example, if the original heights were 1, 3, 2, 2 and x equals to 3, 2, 2, 8, then the increased height will become 4, 5. Yeah, okay, they increase. The goal is to make the heights of all equal towers. To make the game more interesting, D wants to choose an integer k and add a restriction. Each xi must satisfy xi must be less than equal to k. Help him find the smallest k for which it is possible to finish the game. To make the game more interesting, D wants to choose an integer k and add a restriction. Help him find the smallest k, which, okay, the smallest k will be the distance, right? We want to make them of equal height, so the maximum, it will be from 1, so the maximum plus 1 will the k, find the smallest k. Okay, just a minute. Where's my stylus? Yeah, okay, it is here. So this is the original height. Let's say this is the maximum one. So till plus 1, maximum plus 1, it will be the summation of all heights, and each individual xi will be this. This will be 1. Okay. So xi should be less than equal to k. So the minimum number till the maximum height, that is the maximum from here plus 1, is the k. So what we need to do is output a single digit k. So in this case 1 and 3. So 4. 1 to 4, the distance is 3. Yeah, the logic is correct. I'll start coding. I also need the CPOS. Div 3 is so easy. The Div 2 was, I have given only Div 2 contest in the last month, in the past one. So yeah, is this the correct one? No, this is not the correct. Contests and open enter. No problems yet, not started. Do I need to hard refresh it? Just a minute guys. Okay, we'll start. Should we start coding till then? Okay, we'll read the next problem. Yeah, okay. Windows shift, and I need to erase this line. I need to fix a template because it's wasting a lot of time each time I'm writing all this basic stuff. Let's say int min equals to, what is the range each number can be till 2 into 10 to the power 5. So let's say I'll write 2 into 10 to the power 5. So 1, 2, 3, 4, 5, and int max equals to 0. then min equals to math dot min of min max. What is wrong here? Int cannot be what just a second. Int cannot be dereferenced. What am I doing wrong? What is wrong? Max equals to math dot max of max and a of I. This is correct. Int cannot be dereferenced. What is happening? Contains numeric expressions such as this square root. Oh, dot. And it's so small I didn't even notice it was a dot. So final answer will be ln max minus min plus 1. Control save, run all, then public, and yes and no. Is it okay? We need to print yes for each ticket. Yes, if you can make this string entirely 0. Oh, this is a different question. Over. Okay, just a second. This is a completely different question. I need this one. Why can't I see the first one? I'm not able to see those problems. Just a second, guys. The second question, I'll read the second question. During the holidays, E came to visit his friend D in the city of Kazan. Out of boredom, D and E came up with a new business idea to make their own TV show. The format of the show is very simple. In each episode, they invite a guest to play a game on them on a binary string. Today's episode, D and E invited A, aka Makan, the main celebrity of this. For the game, they choose a binary string S, of length n, and an integer k. A can make unlimited number of moves. In one move, he can choose an integer which is from 1 till n minus k. 1 till n minus k. That is the first, all the beginning integers except the last k integers. And invert the characters at the position I and I plus k. And invert the positions at I and I plus k. That is change 0 to 1. We can choose an integer I will be from k distance zone and I plus k. Invert the characters at position I and I plus k. For example, if this is 2 and k is equal to 2, then k plus 2, right, till here you can choose any number. So by choosing I is equal to 2, it inverts the character, so it becomes 0, 1, 2. And if it was position 2 and 4, I is position, okay. Okay, why is this not opening? Contest open, problems not started, open the contest page. Which is this question? 2236A. 2236A. Does not loaded over. Wait, I'll restart the extension. Okay, I think this is correct. I'll submit this. If I get a wrong submission, then I'll let it be. Be confident. Two, 3, 6. There's only a single problem that has synced, but okay. So what is for example, this an inverse, and I want to get the main price of dash. To do this, need to make the string equal to 0. Entire string must be 0. Help determine whether he can get the price or not. Return to the first line contains this. We need to print yes or no. So I'll shift this. I'll just go into home screen. So this is a binary string, and so these are k letters. So from 1 to this position, from 1 to n minus k positions, each this and this is inverted, right? So if this is 1, this becomes 0. If this is 0, this becomes 1, right? Invert the characters at position this and this. That is, change as 0 to 1 and 1 to 0, right? They are not exchanging, it is just inverting. So to make them all 0, the parity should be same at I and I plus k, for I equals to 1 till n minus k. Okay, that's the solution. I'll write it down. So this is the question. Will int and then test cases n and k. So first we take n and then we take k equals to c dot next int. These are the positions, okay? Then I'll input the string s. String is equal to c dot next. Then the parity should be same. Then for I equals to 1, I'll use this positions itself till it is less than equal to n. We'll check if s dot char at I is equal to I minus 1. So positions are this. So s dot char at I plus k, right? I plus k, yes. I plus k minus 1. Continue. Else flag is equal to false and break. I'll need a boolean flag true. F flag, then system dot out. Yes, and print no. This should be correct, except there's no break. Flag is equal to false. Control save, run on public. To run in the CPOS, I need to make it a normal class. Okay, I'll use the 0 index itself. Not till n minus k. Okay, which test case am I failing? 1 1 1. In this case it is 2, so 1 1. So yeah, it should print yes. It prints it, but it is a no because we need to convert it into all zeros. There are some characters left in between. So which are the characters which are left in between are if let's say this position, these are k integers, these are n integers, so this is the n position I am talking about here. This is the n minus k position. So we'll be iterating through this and we'll go position plus k, position plus k every time. If so, in this case, if the total n comes here, so this shifts here by 1, right? What I mean to say is that okay, we are checking from I 1 to k n minus k, okay? For each index we jump a k, we jump a distance k, we jump a distance k, we jump a distance k. So from k to k plus 1 positions we are doing. But what if n minus kth position is less than kth position? That time we need to check if the numbers in between, that is n minus k so what I mean to say is in this case, so let's say n is 5 and k is equal to what should be there, n minus 2k should be greater than 1 or greater than 0. Let me check. N is equal to 2, so n minus 2k is equal to 1. So 1 2 3 4 5. So from index 1 to 5 minus 2, that is position 3, we'll check the two numbers. So this plus 2 is this plus 2 is this. Oh, okay. It is also changing. Just a second. This is a string, right? Binary string. So first and 1 plus k, position 1 and 1 plus k, position 2 and 2 plus k. And once this comes, we also check position 2 plus 2k. So each at a distance k we check. Okay, just a minute, if I'll check if this one is correct. Yeah, okay. So I'll read the problem 3 while I'm not getting an intuitive answer for the second question, so I'll jump on to the problem 3. An annual programmer's fair is taking place and the main square of the city. You as the main programmer of this decide to take part in this wonderful event. At the entrance, guard decide to check your skill and give you a problem. There are three integers a, b and x. You want to make a and b equal. In order to do so, you can do the following operations. You choose one of the integers and add 1 to it. You choose one of the integers and divide it by x with rounding down. You need to find the minimum number of operations after which a becomes equal to b. So we need to output the minimum number of operations. So let's say there is a number a and there is a number b. In this case, b will be greater than a. So what we'll do, we can either go on increasing this, that is b minus a time operations will take. So if this was 2, this was 5, we'll take 3 operations. Or else we can divide b by x number, right? Let's say x was 3. We'll divide x by 3 and round it down. So b by 3 is 3 ones are 3, so it becomes 1. And now what happens is that it becomes lesser than this. And then we'll again check. So this is a and b. This is some p times of x plus r1. This is q times of x plus r2. When we divide these by x, when we divide one of them by x, till they become lesser than p. So we need to make this just lesser than a. Just lesser than a. To make it greater than a, okay. Okay, for each operation, just a minute. For each operation we can either, operations are either, let's say b and a. Each operation has 2 possible ways, that either it will be the sum of the numbers, we can add 1 to it and divide it. I'll use a number line, let's say. A is 3, 1, 2, 3, 4, 5, 6, 7, 8. B is equal to 8 and x is equal to 2. So what is the best way? The number of operations. We can, using the division, we can lower the greater number and we can increase this number. We can increase it by 1, 1, 1, plus 1, plus 1, plus 1 or we can bring it down. So when we divide 8 by 2, it directly becomes 0. Sorry, 8 by 2 is 4. So b becomes this. Then again operation 1 is done, so I can either increase it by 1 or divide. So 4 by 2 is 2. So what I need to do, either we need to bring it down till, let's say this is a, b can come here or b will come here, okay. This is b divided by x and this is b divided by x. This was b initially and b divided by x, and this is b divided by x square, let's say, okay. and x is not the original x, okay, it is the just below one. So either this is the answer, that the number of these operations plus this, or the number of this operations. So I'll start. What will it be is that we need to make it come as close to a as possible by dividing it by x multiple times. The closest it can come to x, and we round down, okay, take that into consideration as well. We round down always. So I think it is beneficial if we just make it above a, or no, okay, I'll do it, okay. So we'll do a while b is greater than a, b divided by equals to x. We'll keep on dividing it, okay, and once this becomes b by x square, just, okay. So we'll find that distance, which will be a minus b, and plus operations here, plus operations, and operations equals to a minus b, or operations, either this will be the operations or operation minus 1 and operations minus 1. So we'll come above this, and it will be b times x minus a. So it will be either of this. So let's code it. Okay, it has directly taken it. So I really need a template, man. I'm stuck just writing this scanner object always. What are you accepting? 3 integers a, b and x. Int a equals to a c dot next. So I'll just copy this and print it 3 times. A, b and x. So if I considered b to be greater than a, right? So if b is less than a, we'll switch it in temp equals to a equals to b equals to temp. Okay, we switch it if it is lesser than. So now b has become greater than a. So I'll run a for loop that while b is greater than a, I need to introduce the operations, right? Int operations equals to 0. While b is greater than a, operation plus plus, and b is greater than a, and we'll do the, if it is greater than a, we'll do the operation, and the operation is b divided by x. So this has now just become smaller than a. So the answer will be int c1 equals to case 1 is, it will be a minus b plus o, right? That these many operations we have done. Or it can be int c2 equals to op minus 1 plus b times of x minus a. And we need to print this. System.println math.minimum of c1 c2. What is wrong here? Int cannot be converted into char. Where am I converting it to char? Sysmath.min. Okay, c2 equals to math.min c1 c2, and I'll directly print c2 itself. So 1 2 3. Okay, the negative is also coming, right? So it will be 0 always. Okay, the logic is wrong. Just a second. So which case? Okay, the last two are okay. 1 2 3 itself I'm failing. So what happens in the case of 1 2 3? Where's my stencil? So in the case of 1 2 3, a is equal to 1, b is equal to x equals to 3. So as b is greater than a, it will divide the number. So 2 by 3 will come 0 and operation equals to 1. Yeah, and so 1 and 0. A is 1 and b is 0. So answer will be operations plus a minus b, which is either 2, or it will be operations minus 1, which is 0, plus b times of a. B times of a is b times of x. B comes 0. B times of x is 0 itself. So b times of x, instead of b times of x, we'll do b divided by b times x. B plus what? Let's say is equal to b 1 divided by x. Okay, we round it down, but okay. So instead of 2 coming here, the answer is 0. So that 0 minus of a is minus 1, so the answer coming minus 1, but the answer should be 2. So when is it a problem? When b is 0, right? B times of x is 0 when b is equal to 0, when b comes equals to 0, and b, how can we come back to, we round it down. All these numbers which are if b by x, if b mod x, the remainder, if the remainder is less than so if b itself is less than x, all that times b comes equals to 0, and I am facing this problem, and for all that times this one answer is 1, but the one which is just above that. So let's say if this was b itself, I'll write, should I write b itself or x? Here what I need to do is so this becomes x and all the lower values are b. So b divided by x comes down to 0, 0, and if a is somewhere here, b is somewhere here. If I do b is less than x, how much less than x? The only is the single operation, so math, so if b is equal to 0, in this case I'll need to use the original b here. Int b2 is equal to b, and if we can't initialize in the condition, so this should work. It is not working. 2. How is it 2? Operations was 1 minus 1 is 0, 0 plus b2 times of x, not b2 times directly b2 minus a. 1 0. Okay, these two am I failing in case of 2 3 2. Okay, why am I stuck? Let's say this is b, this is a, and our x can be anything. If our x is here, then b comes here. And then directly we do this, or then we again do a by x and all. Should we do dp? Is there a dp here? We need to make b is equal to a. So a step before this, it was either that b minus 1 comma a, where it was this, or it was we divide it, right? So b was in between x times of a and x times of a minus 1. B was in between here. Then again there were two options. Is it brute force, right? This is brute force because a and k is 10 to the power 9. I'll solve the second question. We need to make the string all 0. The case I was getting stuck in that if, let's say, there were elements remaining, because this is there another time, because in this case 1 1 1 and k is equal to 2, we check till only n equals to 3. We only check till first character because that is the end. So this is the nth position, we check n minus k position. This is n minus 1. Some n minus I minus k equals to position 1. Okay, this is the constraint. At n minus I minus k is equal to position 1, we have shifted I positions, and from so these are also I elements and I elements. Okay, I'll check till if k should be less than n is equal to, let's say, 4. We'll check each, okay, for 1 2 3. K is equal to 1. These are the 4 elements. So this is corresponded to this. For till third element, this is corresponded to this. This is corresponded to this. Okay, they are interlinked, by the way. All of them were 0 0 0 0 and 0 0, and this is k equals to 2. I'll transform this. We can perform any number of operations. So 1 0 1 becomes a 0 and 0 becomes a 1. Then for all remainder classes of k, the summation remains the same. If it was 1 1, it transformed to 0 0. If it was 0 1 1 became 0 0 became 1, so summation is unchanged. If it was 0 and 0, it became 1 and 1. So either it remains the same, or it decreases by 2, or it increases by 1. And finally we need all the summation to be equal to 0. So if the summation of all the elements modulo k, so k, right, so all indices divided by k will divide this. If it is 1 2 3 till n minus k, if all of them are even, then it is true. That is the logic. So how will we implement this? That all the n numbers with these are the positions I equals to 1 till I equals to n. So array list or a size array will directly season an array that is remainder class of k. So it will be from 0 to k minus 1, which will correspond to this remainder being 1, and remainder 0 is also possible, right? So from remainder 0 till k minus 1, yeah, these are the remainders itself. So if j equals to I mod k, and we'll add that element in the array of j plus equals to s dot char at I. This is what we'll do. S dot char at I, and I'll define an array of size k, and from 0th character till nth character in j equals to I plus 1. These are the positions mod k, and we'll store a of j plus equals to, all of them are 0, s dot char at, if s dot char at I is equal to 1, then we'll add one, and finally we'll do a sum for int lna sum plus equals to l. Yes, no, yes, no. Will printing all, yes. For all the elements in array A, I am adding them. If this that current I is equal to 1, I am adding it in the remainder class. Remainder class is the position mod k. So A of that k will increase. Okay, I'll need to debug this, right? Oh, I didn't save it. Was that the problem? No, that's not the problem. So in this case, the remainders are 1, 2, 3. So in this case, 2. So 1, these are all of the same. Not the summation, the individual should be 0. Flag, I need flag. Boolean flag equals to true. And if for all the integers, if L mod 2 is not equals to 0, then flag equals to false and break. Boolean flag equals to 2. What is wrong here? Is already defined. Yeah, it's already defined. And if flag, then print this. Else system dot print reach the end of file while passing. We need this outside of the loop. There's no need of the summation. For all the array, if mod 2 if either of the values are odd in the array A, then it is false and will print no, as in this case mod 2 is, here it is position 101, right? So this is 2 and this is 1, so this should print no. Why is my program not printing? I need to print this. System.out.print zero. All are 0. Why is it 0? I'm checking if s dot character I is equal to 1, then I adding 1 to the of that index. So new array of size 2, it will be, remainders will be 0 and 1. So for the first position, that is 1, a of 1 is 1. This is not a this. God damn it, man. Cool. This was a cool experience. Yeah, now it works. I just need to write public here. And submit this. So the second one is done. We'll move on to the third one. Third one says, we are rounding it down. Again, let me go over here. How much time is left? Yeah, in 30 minutes, right? I guess in 30. What's the time? 9. In 45 minutes. In 45 minutes, I have solved 2 questions. I need to solve 2 more. I'll read the question detail then. The third one is about these only, right? If I think there won't be a problem unless and until there's an overflow. Let me check. I'll just. Okay, the queue is long. D and E were not satisfied with the fame from the previous episode. They decided to make another TV show. The guys play the favorite game on an array A with the favorite integer K. D moves first. On the first move, any element from the array can be chosen and removed. Let the previous chosen element be equal to X. Then on the current move, an element can be chosen and removed. In the current move, except the very first one, a player must choose an element y from the array such that y minus k is equal and remove it from the array. From 0, a y such that y minus k should be either 0 less than equal to k. Y minus x. Y minus x means it is above the element, the number is greater than x and it is less than equal to k distance. Okay, and remember, the player who cannot make a move loses. So there is an array. Once we play a number, we cannot play it again, so we can remove it. If we choose a number, let's say 3, number 3, we remove it. So the next player needs to choose a number and k is equal to 5. You can choose a number from 3 to 8, and if there is a number present, he chooses so that the other person should have a problem. Then he will choose the minimum, which is 3 itself. Once he chooses 3 again, so it becomes 3 is taken and removed. So the next number should lie from 3 to 6. Likewise. So for first player to make the move, he will choose the minimum number. Let's say 2 is the minimum number. There are 2, 4, 8, 10, 12. Because once we choose a number, he can only choose a number which must be 12 or 24, till 12 or 24 in this case, such that number minus x should be less than equal to k. Sorry, this 12 plus k, till 12 plus k only he can choose, right? For any number chosen from this number to plus k numbers he can choose. So for winning, what will the players do? He'll choose the maximum number because there is no number that is greater than equal to that. Hello. Hey, I need, what is this? Say, can I copy this? Okay, let it be. Damn, it's still in queues. What the hell? So, what was the announcement? Note. Where was the announcement? I can't see the announcement. Can I see it in here? Yeah, announcement. Yeah, translate this shit. Why can't I copy this? Yeah, okay, I can copy this. Windows we translate in English. Damn, what is this? Translate. Ah, I guess it is Russian. Yeah, the Russian version of the problem D has slightly changed. Now it's clarified that the selector number is deleted on each turn. Reload the condition page to see the changes. I can't see the changes, but okay. In each case we'll print 10. The first line contains two integers n and k. The length of the array n k contains n integer. For each case, if there exists such a first move that with optimal play by both players, Igor wins. Who plays first? Whether A can make the first move for a beer, no matter how do we plays, Igor wins. Okay, D and E are not satisfied, so D moves first. On the first move, any element can be chosen and can make a loss. But since this was not just a game but a real show match, A, the main celebrity, was invited again. As a guest celebrity, A was given the opportunity to make the first move in this match. That is the first move in the game instead of D. However, it turns out D is a fan of E, so he wants his first move to guarantee Igor a winning strategy against any response from D. So determine whether it is worth. So the first move should make the second person win. So if I choose this number, there is no number greater than k, so he needs to choose another number from here and another from here. All this is shit. If we choose a number in this sorted list, we can only select all the numbers which are less than the difference is less than equal to k. So all these numbers are valid. We want E to win. That means after making the first move, there should be a move such that E wins. If let's say there are the greatest number are, there's only one greatest number, so D chooses this and A loses because there is no other greater number than this. But if there are two, then E can choose this greater number again because we have removed this, and there's another one. So if in an array we need to find the frequency of the maximum numbers. If it is yes or no, right? We need to print yes or no. Yes. So if the maximum number is odd, then we need to print no. If the number of maximum number is odd, in this case the maximum number is 1. In the first example it is possible. In the second example, can choose integer 1 as the first move, then Igor will choose integer 2 and the beer will have no valid moves. If it is odd, 1 2 3 4 5. Okay, it is possible if it is odd because we choose a number which is slightly lesser than that, right? So in this case the greater number is 3 and it is possible. It is odd and it is possible. How? So it will be D, E, D, E. It is also possible if it is odd and there is a number and the number less than that is also odd. The number slightly less than that. if from the greatest one, so the greatest is 3, so it will become 210. In case the greatest is only 1, so and the greatest is 1 odd, it is not possible. If in this case the greatest is 1. Okay, so what I have observed is that, let's say these are all the numbers, okay, and I'm saying these are all the distinct numbers, and these are in ascending order, and let's say these are the number of these numbers, that is the frequency. Okay, so if the frequency of the greatest k integers is even, then it is possible, else it is not possible. So we need to make an what is the range of the numbers. Each number is from 1 to n and is still 2 to 10 to the power 5. So we'll create an hash map. Where is my skeleton? We'll put a hash map, and for each number we'll note down the frequency, and then we'll note down the maximum number from all those numbers, and for all the numbers that are at a distance k from the maximum number, that is if maximum is 6 and k is equal to 2, so it will be 6 and 1, that is 5, 6 and 5. Okay, so all the frequencies of 5 plus 6 should be even. If it is odd, then it works. Okay, the greatest k numbers, the frequency of the greatest k numbers. Sure. Yay, got this. So I need C and D. C I'll again skip. I'll use the D question directly now. Yeah, let's start. I'll copy paste the template now. I'll take an integer number, and then I'll take 2 integer numbers, that is n and k, and I'll create a hash map of integers. A new hash map of integers will be this, and I need to sort this. So the collections.sorts directly work, right? What is this? Construct an empty hash map with default. Yeah, what's wrong? Reach the end of file while parsing. Array man. So for int I equals to 0 till I plus plus, and m dot put the number we need an x. M dot put in the place of x, m dot get or default of x comma 0 plus 1. Get or default will increase the value, and also we need a max, right? If it's sorted, it's directly done, right? So we'll sort collections dot sort. Can we use a array list? No, because we need frequencies also, right? We can directly count the frequency in the end. I'll use an array list, let's say, or array. A new event and directly a of I equals to s dot next int, and then we'll sort and after sorting the array for int I equals int j equals to n minus 1 while a of j minus 1 is less than equal to a of n minus 1 minus k, while that element is less than equal to this element, will add the frequency and frequency equals to 0. G equals to reach the end of file while parsing. Int j, where is j? What the fuck is wrong? Okay, we'll increase the frequency if f mod 2 is equal to 0. Else will print no. Will I get a TLE? Yeah, TLE. So I need to use a hash map. A new hash map and How do I sort a hash map? Okay, j minus minus. I could have done it using array. Just a minute. I didn't decrement the. Will increase the frequency and will decrease the. I'll get a TLE here. I didn't save this. Save and again. At index minus 1, from index minus 1, so 5 1 1. So the 1 is the 3. J minus 1, not J minus 1, it is J itself. J itself, right? N minus 1, it is 3. 3 is less than or equal to A of N minus 1 minus less than equal to K. In this case 1 2 3 4 5 5 is odd, so we'll print no. The greatest, we start from n minus 1, and if from the greatest number the difference is less than equal to K, we'll subtract it and we'll add it to the frequency. No. Okay, yes, I've gotten a yes here. I need a yes at the last. There are 3, so I need, how is it possible? 1. If it is not equal to, it will be just less than. I choose a number 1, then he chooses 1, then I'll choose 5, then he chooses 5, then I'll choose 5, and I win. In the other case, I'll choose 5. I'll choose a 5, he will choose 5, then I will choose 5, and he loses. I don't need that. How can he win in this case? In 5 1 5 1 5, how can he win? So 5 1 5 1 5 1 and 5 elements. K is equal to 1. So 1 1 5 5 5. Let's say D and E are playing, right? D's first move is this, E's first move is this, then D, then E, then D. D plays this and E has no chance of playing, so E loses. Again 1 1 5 5 5. If D chooses this, E has to choose this, then D has to choose this, and then again if we choose this, E lost. I'll read the question again. from the previous element chosen equal to x, a player must choose an element y which will be from x till x plus k. He can choose an element from x till x plus k. Each person can choose an element from x to x plus k. So for winning, we just need the summation of the numbers. Okay, these are the greatest numbers, and let's say this is the greatest number and this is the greatest minus, this comes under greatest minus k. So greatest plus k is this, so it is valid. So from here till here, if the summation is even, it is possible, but in this case it is 1 1 5 5 5, or is it 3 5s and 2? It is, yeah, 3 5s and 2 1s. 1 1 5 5 5. How is it possible? If we choose a number, we can only choose a number this till a number greater than that. Oh, till a number greater than that, right? So we need, this is also possible. We need to find a block whose frequency is even and there is no other number from 1 to, from that block k, from that block till block plus k. We need to use a hash map, guys. Again I'm changing hash map of integers, hash map of integer and integer. M equals to, there is no need of the greatest one, we just need to find a one which has no other elements. And even if it contains that elements, the summation should be equal to 0. So it is either so the summation of all the frequencies for a number till number plus k should be it is a sliding window. Okay, so sliding window, the frequency of all the numbers should be equal to 2. What I mean to say is, let's say these are the numbers, right? These are the numbers, and for all these numbers have been marked to a particular frequency. This number has occurred this many times, and these are arranged in increasing order, right? All these numbers are in increasing order. So there's no need of, there's need of increasing order, because we need to find if a block is this 2 seconds, and 10 to the power 5 k integers, right? So k, so for all the numbers whose difference is k, so for each particular number there is a range for all the greater number than k. So the frequency of that, all those should be equal to even. For this number, all the elements which are greater than this by a factor of which is less than equal to k. So for each there is another value. and if that value is even, then we are done. What can I do? A new hash map and x equals to s equals to x. Default x minus 0 plus 1. We put all the frequencies in. And then we sort this. And how can I sort it? Do I need to sort it? Yeah, I'll use another hash mark. Let's say I'll put the name as W. For all these values, I have another value. Right. And for each value we need to put in. For all integers, for all the entry set, right? For all the keys I need to find. So for all the keys, how can I put all the keys? Was it something like that for map dot entry e to end maps entry set? Was it something like this? Iterating through a hash map. Map dot entries. Entry set. M dot entry set of integer comma integer e, which belongs to M dot entry set. Is there a plural? M dot entry string comma string set entry set. For all these, is this E here? Okay, what is wrong? For map dot entry of integers and integers E such that M dot entry set M dot entry set. Is it for each or anything? Okay, I have done the same thing. Why is it not working? For each, does that work? For each. And dot for each key. This does not work. For map dot entry of integers comma integers e such that empty set. Okay, for all this value so int frequency equals to 0 and w dot put in place of e dot key comma f. I need to put in f. E dot key get key, get value. So e dot get key, and for each of that e of get key we need for all int, let's say j of m. For all the key sets we need, for all the key sets, another for all this. Integer, let's say er, now it is r. For each r, if e dot, if r dot get key minus e dot get key is less than equal to k, if plus equals to r dot get value, not r dot get value, we need e dot get value, and that e value, no, r dot get value, right? X including that number. So yeah, e dot get key, we add the frequency and put that frequency into w. Now for all w, if there is an even w, then we need to print f. Flag boolean flag equals to, let's say, false. If for all the integers t belonging in w, for all the t in map w, if t mod 2 is equal to 0, then flag equals to true and break. For all the integers of w. What is a w? W is an hash map. T cannot be used, we need to put, let's say, y. So for all the y, if it is for each not applicable to expressions required array okay, I need to put this again. Of w, if e dot get value else system dot out dot println no. Println no, yeah, what is wrong? Println, not println. Println, yeah, what's wrong? Else system dot out dot println. Reach the end of file. No, yes. So in this case, is there any block at a distance of 1? So 3, 1, no, I should print no. Let me print all the values. System dot out dot print e dot get value five. Okay, then there are 3. How is it 3? Yeah, that is 3 and 3, then no. X say x plus k, so 1 plus 2. In the second case, how does he win? How does he win in the second case? D is 112 and there is a possible answer. So it is 112. D chooses this, then A chooses this, then D chooses this. So he loses. Sorry, because k is equal to 1. So if we choose 1, then 2 is up for choice. If we choose x, then y can be from x till x plus k. And k is equal to 1 is this case. So 1 plus 1 is 2. So 2 can be chosen. Is there an explanation for 2? In the second example, you can choose integer 1 as a first move. Igor will choose integer. Yeah, Igor will play optimally, so he will choose the greatest one. He will choose the greatest one. 1 2 3 4 5 it is not possible. Yeah, it is possible. It is possible. It is possible all over this. Three plus one. In this case, when it's the same, right? The last second case in 1311. 1311. Let's say D chooses this. Then as in this case D chose this and A chose this, and then game is over. So in the same way A will choose this and the game is over. So it should print S. How is it not possible? E plays optimally. So optimal is to play the greatest number. So the greatest number in the last second case, it is not possible for E to win. 1 1 3. These are the numbers. D chooses first, he chooses this because A wants to play, and if A wants to play, A will choose this, and then game is over. But you are saying that A will choose this and B will choose this, then A will choose this, and again game is over. But if we do 1 1 1 3, D will choose this and game is over. That's what it is saying. We need to make A if only greatest number are there, then the greatest numbers should be even, or else if it is odd, then we need another number other than the greatest number. Okay, I'll choose the C question because there is only 45 minutes left. So as the C question says A and B, we can either this or round it off. We can either B number, A number and X number. B is greater than A. So to bring them, we need to bring them as close together as possible. So when we divide B by X, what are the possibilities? B by X. So let's say X is these many blocks, right? So blocks it is. So when we do B by X, the number of blocks, it gets reduced. Either it will be greater than A or it will be lesser than A. If it is lesser than A, should we decrease it by 1 1 1 1, or should we divide A by X and then by plus 1 we moving one step ahead, okay, and by X we are moving down by a lot. Let's say by a factor of, if B is equal to 17 and X equals to 3, so it becomes 5. So we are decreasing it by a factor of 3 approximately. It becomes A by 3. That is, yeah, it becomes A by 3, right? And X equals to 3, let's say. So we either increase a value by 1 or we decrease the other value by 3, which is if the distance between them is greater than x, is greater than 3, that means if it is 5 and 20, then we'll decrease it by x, then again, so x equals to 3, so it becomes 3, 6 are 18, so it becomes 6. But now as the difference, let's say the difference is 3, so it becomes 8 and 5. 8 and 5, what is preferable? 6, 7, 8. So do we do 3 steps like this, or do we do 8 by 3, which is 8 2s are 6 2. Okay, we decrease it till the difference is less than, if the difference is greater than, if math dot absolute, till math dot absolute is greater than x, we divide it, and if let's say it was x equals to 100, this number is 20, this number is 50, yeah, the difference is 50 minus 20, which is 30. 30 is less than x, so you are saying that I should plus 1 is only possible if the difference is, should only be done when the difference is equal to 1. If the difference is 2 or greater, we should always divide. That's what I'm saying. So 100. So what should we do? According to our case, we should use these jumps, because it is x, but if we do b by a, x by a, 0, 0, we come to the same number. So we should always divide unless and until we always do, if 2 steps, okay, I think it is 2. Is it 2 or 1? So I think it is always beneficial to divide the greater number by x, unless and until, let's say it was at distance 2, right? So 2, 4, and k, x equals to some, what can be x? Let's say x equals to 3. So in 2 steps we reach this, but here 4 by 3 is 1 and then 1. So division is always suitable unless and until the difference is 1. So unless math dot absolute is, unless math dot absolute of a comma b C1 So while b is greater than a, we'll increase an option and we'll divide it by x, while b minus a greater than 1. We'll do this, and once it becomes that, we'll directly print system dot out dot println o plus 1, and we'll divide it, and we'll call the function s using a comma b. 3 2 0 1 1 1. Okay, which case the third place, the 10 10 2. This is also not the correct logic. What is the correct logic? 10 10 2, right? 10 10 2 a b x. Oh, if it is same, then we'll print 0. And the other case is 2 3. Seventeen 3 3. 17 3 3. So 17 by 3 is 5. So 5 by 3 is 2. So 3, yeah, 3 should be, I should be getting 3. Int operation equals to 0, and b minus a is greater than 1, operations plus plus. Int a1 equals to a, int b1 equals to b. Yes, a1 equals to b1. Number of operations plus 1. In 17 and 3, in the case of 17 and 3, 17 and 3, the answer should come 3, but I am getting 1. How 17 plus 17 and 3? 17 by 10 is 1. 1 and 3. 1 3, so 3 by 10 is 0 0 and 1. 3 by and 10. 1 and 3, so we should perform another operation. So operation is done, so operations are 2, and the 2 becomes 1 and 0. After 1 and 0 we stop and we print operations plus 1, so 2 plus 1. Why is this not working? In 1733, 1733, right? Temporary equals to A is equal to B, and B is equal to temp. We'll sort this, and when B minus A equals to A is equal to 3, B is equal to 5. Operation 1 is done, this comes, and after that operation number 2 is done, and this is done, and after this operation number 3 is done, and this after operation 1, after operation 2, after operation 3. So 3, yes. How much time is left? 30 minutes. So question D says that optimal, what is the optimal play? In each, after we select each number, let's say there are these many numbers, right? And they all have matched, of these are in increasing order, so let's say 2, 5, 7, 8, 9, 11. These are the numbers, and the frequencies are 1, 2, 2, and 3, 5. So what optimal play looks like is that always select the greatest number, or always select the number which has no block. So in 1, 1, 3, 1, 1, 1, right? The optimal play is either to select the greatest one, and if there are a lot of numbers in the greatest one, if there are a lot of number in the greatest one, if it is odd, then D wins, right? I can't see the test case too. Yeah, I can't see the test case. What is wrong? Edge cases. So there are numbers. I considered B is greater than A, and there is an X present. So it is always optimal to divide it by X divided. So in 20, 21, and if there is 22, and X equals to 21. So 2 plus operations will get you there, or else, according to my theory, the greater number will always get divided, so it becomes 22 divided by it stays 1 and 20. 1 and 20. If it is, the distance is 2. Yeah, we should do this. So in 20, 22 and 21 the answer should be 2. But according to my one, so 1, 20, 22, 21, the answer should be 2, but I will get 3 according to my yes. I'm getting 3. So it is greater than 2. 1 1 2 3 0 2 3. In this case I'm getting 3. 162. So 162. So 6 by 2 is 3. additions plus 1 because the next division directly gives us the answer. Else we need 2 steps. I need to solve D. I definitely need to solve D. So D says we need to choose in each game. Right. What does optimal play look like? When we choose a number, we can choose a number from that number to a number plus k. So range becomes that previously chosen number till x plus k. So let that be have a frequency of f, x plus f. If there is a way that this number if we play any number, what will he want to do? A current player. If a current player has odd frequency, then he wins. So this will want even frequency. He will want an odd frequency. So what I have calculated is the frequency if we play this number. Then our frequency is. If we play this number, then our frequency is. Because it is from this number to this plus k number, right? This is what I've stored. Let's say if in this there are 3 blocks and I play from block 1. He will directly jump to block 3 and skip the block 2. Or he will want a block which has only 2. It's all on frequencies. If the frequency when we play this is even 1 1 3 and it is 1, one one 5 5. So I play 1, he plays 5, I play 1. In this case 1 1 1 5 5, how does A win? Because that's what is given, right? That in this case he wins. A wins. There is a way in which D chooses the first one and E wins. 1 1 5 1 5. One 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 5 5. When we choose a number, we remove it and play a game with the favorite array and k equal to x. Then on the current move, except the first one, a player must choose except the first one, a player must choose an element y from the array such that the difference is only till k and remove it from the array. Then a player who cannot make a move loses. The first plays something, then as the case do we F it up on? I'm not understanding. Just a minute, I'm thirsty. I'll get some water and come. So there are numbers b and a. We either increase a value by 1 or we decrease it by a factor of x, and we need to make them equal. If the difference is 1, then we'll directly use this. Else it is preferable to use this, right? Because we round off and come here. So if the difference is, let's say, if the difference is, like in the case of 162, right? So it was divided by 3, so it becomes divided by 2, so it becomes 3 1. Then again, if divided by 2, it was 1 1. So just this works. But if the difference is 2, okay, which was the case in the given? 162, answer is 2. And what am I getting for 162? I'm getting 2. We should divide it always, unless and until the difference is 2. Why should the difference 1733? Which is easier for me to solve, this one or this one? I think I should solve C. I'll be able to solve both if enough time is there. Okay, there's 14 minutes only, but I'll give 5 minutes here and then I'll again switch if I seem like I'm not coming close. Choose one of the integers and divide it by x with rounding down. So we'll always choose the greater one and we'll divide it. And once we divide it, it will be b by x. Now b by x and a. Should we divide it or should we add a? Should we increase a or should we divide b by x? We will divide b by x. So it becomes b by x square. If b by x and b by x square. So the difference here is a. sorry, b by x minus a, and the difference here is b by x, a minus b by x square. And again do a by x. We'll just keep on dividing until the difference is 1 and then use that instead. Till the difference is greater than 1, we'll keep on dividing it, we'll sort it, and if it becomes 0, then the operations, if there are imaginary equals, else we just need to print this. We'll keep on dividing until the difference is 1, and once the difference is 1, we'll print it out. If the difference is 2, we'll get 1, 2. But if the difference is 2, we'll 1, 2, 3. So it's like, let's say the numbers are x, x plus 1 and x minus 1. So x, and let's say this is a, this is b. So what will my algorithm do? It will divide it by n, so it will become 1 and x minus 1. Then again divide this, so it becomes 0 and 1. Operation 1, operation 2, and this will be operation 3. So 3 operations, but according to this, it is that. So when is the answer 2? The answer is 2. Instead of 3. Here itself we add 2 instead of going on dividing. Why is it? Or can we do like this? This, if it is this, so we'll do x and x plus 1, and then we'll divide x by x plus 1 and x, right? So we'll divide it, becomes 1, it becomes 1, it will equal, so 2 moves. If b is greater, right, and a is this, if a plus 1 by x is not equal to b by x, we'll go through the division, and if it is equal, we'll come out of the division loop. So what was my test case? It was, let's say x is 5, so it was 7, 5, right? 7, 6, 5. 1, 7, 6, 5, and the answer is 2. In 2 moves it should be. Not 7, 6, 5, it is 4, 6, 5. So answer should be 2, but according to my, it will come as 3. So Yeah, 3, but I need 2. It is either that or that. So I'll and a plus 1 by x is not equal to b by x. We'll perform this operations, and after performing those many operations we will either print 1, else if b minus a equals x. Four, 6, right? So b a plus 1 is 5. 5 and 6. 5 by x is equals to 6 by x. So once it is false, we'll come out of this loop. Now the difference of this is 2, so we'll print number of operations plus 2, which is 2. In this case I'm getting 3. 1, 6, 2. So 1, 3 and 2. 1, 3 and 2. So it is either 1, 3. It is, we stop at 1, 3 because we stop there and we print instead 1. So what are the cases when the difference is equal to 2? Either case is that after one division, example 1, 3, 2. So after one division they become equal. Else another condition is that after 2 plus they become equal, or else after one division, or after, and what was this case? This was x minus 1, x and x plus 1. So 4, 6, 5, right? In this case what we were doing, it difference is 2. So 1 plus and 1 division, plus and division. So 132, when it comes to 132, 132, it should be b by x equals to a by x, right? 13. So it should be 2, and here it should also work. 302. And why am I getting only half of the answers? So in 1 and 2, answer should be 1. Operation plus 1, because b minus a equals to 1. 2, 3, 3, 7. The difference is a lot. Four by 3. Okay, third test case, first and third. 3, 7, 10, right? So 3, 7, 10, 2 divisions. B by x is equal to a by x. After that 3 and 4 and 1, 2. Else if the difference is 1, then we do operation. Or b minus a is equal to 1, and here I'm just brute forcing it very hard now. Each wrong submission costs a lot, and I am giving a lot of wrong answers. I need to solve D in. Okay, the contest is freaking over, man. Okay, that's it, guys. Again, how many problems did I solve? Just 2 out of 4. I'll just check if this is the last. The fourth one is, yeah, the fourth submission is also wrong. Okay, thank you, guys. Love you, Shravani.